Welcome back. This is the video on graphs of linear equations, and the first question that we really need to answer is, what is function form? And this question is really the basis of graphing because we need to get things into function form in order to graph them. And so if you'll recall, what is function form? Function form is y equals a times x plus b. We've solved for y. That is the crux of function form, solving for y. And so if I'm going to try to complete this table with the domain -4, -2, 0, 2, 4 and plot the points on a graph, I need to know what the function is. And the function is going to be y equals, notice it must be in function form, 3x plus 2 because it's y equals. And so I'm going to plot these points after I find them. So let's see what we've got. I like to make an XY table. And if you want to do it vertically, that's fine. I've got a horizontal one here already drawn for you, but if you want to do a vertical one, that's certainly possible as well. You would have -4, -2, 0, 2, and 4. I'm going to go ahead and use this chart up here. In order to solve these, I'm going to plug in what I know. So y equals -3 times -4 plus 2. Well, -3 times -4 is 12, plus 2 is 14. So my first point is -4, comma 14. Y equals 3. Oops, I did that wrong. Go back, go back, go back, go back. It should just be 3. I'm sorry, guys. It should just be 3 times -4, which is -12. -12 plus 2 is -10. Sorry, guys. So this is going to be -10. The second one is going to be 3 times -2 plus 2. So that's going to be equal to -6 plus 2 is -4. So my second point is going to be -2, comma -4. If I put in 0, y equals 3 times 0 plus 2. So that's 0 plus 2. So my third point is going to be 0, 2. If I put in 2, it's 3 times 2 plus 2. This is not new to us, guys. This is stuff that we've done before already. So 6 plus 2 is going to be 8. So 2, comma 8. And 3 times 4 plus 2 is 12 plus 2, 14, 4, comma 14. Now, notice how this works. When I'm going to go to plot these points, I'm going to try to recognize the relationship between them. So let's see. -4, -10. This happens sometimes where I run out of axes, and so what I'm going to do is I'm just going to put in a couple more points. So this will be -7, -8, -9, -10, 7, 8, 9, 10. So I just had to put in a couple more axes. That's fine. And I'm going to plot these in red. So -4, -10. So I go to -4 and I go down to -10. Well, notice I am off the chart here again. 6, 7, 8, 9, 10. We're all the way down here. So -4, -10 is going to be down here somewhere. And I've got -2, -4. And then I've got 0, 2. I've got 2 and 8. And I've got 4 and 14, which is up here somewhere. So I'm off the charts. I wanted you to see this. See how this goes? It's actually going to be up here somewhere. Okay? So my points go in a line. You see that? They're going to be generally in a line, and that one's probably off because it's off the charts. Notice, it's generally a line because this function form is graphing of a linear equation. The equation is a line. Y equals ax plus b is a linear equation. What are some examples of linear equations? They would look like this. Y equals linear equations. Y equals x minus 1. That's a linear equation. It's in the form of a, which is a constant, times x plus b. Also 3q plus 5q equals 16. What about s equals 0.2t? Those are all linear equations. What about these? Not linear equations. Things that are not linear equations would look like this. 24 equals RT. That's not a linear equation. Also, a squared plus b squared is equal to c squared. Pythagorean theorem, not a linear equation. So notice, I've got two different variables with constants and some numbers. Those are linear equations. How do we plot these? Well, let's see how we do this. We're going to do the same process. Do the domain, do the range. Y equals 1/2 x. Pick convenient domain. If I pick a convenient domain, I'm looking at this. What's something that easily multiplies by a half? So I'm going to pick -4, 2, 0, 2, and 4. Why? Because -4 multiplied by a half is easy. -4 times 1/2 plus 1 equals. So half of -4 would be -2, so -2 plus 1 equals -1. So my first ordered pair is going to be -4, comma, -1. What about if -2? So -2 times 1/2 plus 1 equals -1 plus 1 equals 0. So my second ordered pair is -2, comma, 0. What about 0? 0 times a half. See, 0 is a convenient value to pick because a lot of times it will go away because it's multiplied by something. And anything times 0 is 0, so this is 0, comma, 1. 2 times a half plus 1 equals 1 plus 1 equals 2. 2, comma, 2. 4 times a half plus 1 equals 2 plus 1 equals 3. So this is 4, comma, 3. Now, step 1, find the points. Step 2, plot the points. So, -4, -1, -2, 0, 0, 1, 2, 2, 4, 3. Notice, these are a line. They are a line. This is a linear equation. Pick a convenient domain, find the points, plot the points, connect the dots. Okay? That's as simple as it is. Here's another one. Let's graph this one. From scratch. I am going to pick convenient domain. Pick something easy. Pick something that's usable. If I've got x plus 4, convenient domain, -1, 0, 1, 2. Okay? Only have to have about 3 or 4 points. So we're going to pick a convenient domain. Let's make a table. X, Y. -1, 0, 1, 2. Number 2, find points. Well, if y equals x plus 4, y equals -1 plus 4 equals 3. So my first point is going to be -1, comma, 3. Next point. Y equals -1, whoops, Got to remember what we're putting in. 0 plus 4 equals 4. So my next point is 0 comma 4. Y equals 1 plus 4 is 5. So my next point is 1 comma 5. And my final point, because I only need about 3 or 4, is y equals 2 plus 4 equals 6. So my point is 2 comma 6. Let's plot them. Negative 1, 3. 0, 4. 1, 5. And 2, 6. Check that out. It's a thing of beauty. They're in a line. It's a linear equation. All right, that's how we graph these. Here's an example for you to try. I want you to try to graph y equals x plus 6. So go ahead and pause here. If you didn't print out the notes, pause here and write this one down. Plot that one. I'm going to give you a hint. Make an xy table. And the next one's going to be y equals 1/2 x minus 7. All right, guys, thanks for watching. That's the first part of graphing linear functions. Remember, we're just putting together things that we've already done. Thanks for watching. We'll see you next time.